Hello and welcome to this Realize Live presentation on leveraging the digital twin to create compelling technical documentation. My name is Ali Nadimi and I am an application engineer for Siemens Digital Industry Software, and I'll be your presenter today. In today's session, we will go over some challenges faced in creating technical documentation. We will introduce Solid Edge Technical Publications, and MBD that will help you with those challenges, and we'll finish it off with some next steps. If you look at the concept of a digital twin, the ability to create a detailed 3D digital model of your proposed equipment and use this as the basis for all areas of product development, it covers all these areas, starting with concept and detailed design, prototyping, simulation, manufacturing, installation, and service, and then round that loop again. And we have to create documentation at many of these stages in the development cycle. And these are just some of the documents you need to create, update, and publish. Some examples are installation manuals, commissioning guides, online spare part catalogs, and so on. So all of a sudden, as you can see, documentation becomes a major task for everyone. The good news is, for most parts and assemblies, 3D digital models are created as part of the product development process in form of computer-aided design or CAD files. Unfortunately, converting those 3D CAD files into technical documentation can be a painstaking process that takes time and expertise. The task of converting files and managing additional files for documentation purposes usually falls on your busy designers. Sometimes instead of converting the files, the designers provide bitmap screen captures of CAD images with a specific orientation to be used as is or recreated by illustrators. All these projects take designers away from day-to-day work. To save precious engineering time as an alternative to converting CAD files, some manufacturers are still taking photographs of a physical prototype to create graphical content. Of course, this means the prototypes must be manufactured first. While 3D models are an accurate source of product information, creating documentation is often one of the last steps in the product development lifecycle because of the need to ensure documents accurately reflect the final design of the product. But since the process of creating documentation can be so time-consuming, ship dates can be held up by these documentations. Ready-to-ship products sitting on the shelf because they are waiting on required documentation frustrate the design team as well as customers. Getting to market quickly can mean the difference between a competitive edge and lost revenue. And meeting customer milestones for product delivery can mean the difference between a profit or contractual fees. The goal, however, is to have the ability to build publications and other documentation in tandem with your design. And not only to build in tandem, but also to keep them associatively linked. This offers manufacturers several advantages. Illustrators have more time to detail their work. In addition, they don't have to worry about a design change down the road, evaluating everything they're currently doing. This research from Lifecycle Insights shows that engineers are spending a lot of time on non-value adding tasks. Engineers spend on average 5.5 hours a week creating drawing documentation. With 3 engineers, that amounts to over 16 hours a week of non-productive time. And that is before time you spend explaining or clarifying drawings to your colleagues. And with machine operators, they also get sucked into the documentation world. spending over 4 hours each on generating additional documents. Also, your consumers don't always have the CAD tools you have or the ability to use them. For example, this research found that 58% of downstream users, for example, a team leader for assembly operations in manufacturing, do not have access to 3D CAD tools. If you look at the problems this creates, for example, difficulty communicating how a product should be manufactured, you may have to scrap and rework products. So how can we help? With Solid Edge Portfolio. Let me introduce it to you. Solid Edge is a key part of the Siemens Accelerated portfolio and is focused on the requirement of small and medium-sized manufacturers. Solid Edge enables manufacturers to create a comprehensive digital twin of their products and includes solutions for mechanical design, electrical design, simulation, manufacturing, and technical publications. It also includes solutions for data management for all the technical data that is created and consumed when supporting the comprehensive digital twin. It facilitates collaboration both within manufacturing companies and with external resources, including suppliers and customers. Solid Edge is the on-ramp to digital transformation. Now, here's some of the key challenges around mechanical design that we have identified talking with designers and manufacturers of products in many different manufacturing sectors. Solid Edge can help your performance in all these areas, but our focus today will be on creating accurate and accessible technical documentation. So let's get started with Solid Edge Technical Publications. Solid Edge Technical Publications offers a wide array of various capabilities, from single-page illustrations to entire sets of documents, including interactive 3D view, text-based instructions, and Excel-style charts. Solid Edge Technical Publications allows customers to deliver customized documents, all while providing users options and flexibility on how they wish to work. The workflow is very simple. Users can import a 3D model, make their document, and update it on the fly. Then with our universal delivery options, it's possible to export and host the 3D documents and manuals on an external website, local server, or just print and share with customers. Furthermore, Solid Edge Technical Publications is very flexible in how content is both created and accessed. Both Solid Edge users as well as non-CAD illustrators have the ability to easily create documentation. For the situation where the CAD designer is also the one creating the documentation, Solid Edge Technical Publications can be launched right from within the CAD interface. For non-CAD illustrators, Solid Edge Technical Publications can be launched outside of the CAD environment. If access to CAD data is available, illustrators can insert it on the fly. If CAD data access isn't available, illustrators can still create documentation by opening a unique file that can be generated right from the CAD data. Now let's see a demo of Solid Edge Technical Publications in action. For example, we'll look at how Solid Edge's new technical publications product can help you improve productivity and drive up customer satisfaction. This is accomplished by tight integration with Solid Edge CAD data, bringing all important information directly into the technical publications product of the choice. This includes model geometry, file associations and properties, configurations, exploded views, and PMI data. Solid Edge Technical Publications offers two levels of product solutions. The first is Solid Edge Illustrations, which is intended for creating single-page illustrations based on a delivered set of templates. And second is Solid Edge 3D Publishing, which we'll be working with today. 3D Publishing is used to build entire sets of documents, including interactive 3D views, text-based instructions, and Excel-style charts to deliver customized document form fit to your needs. Both Solid Edge Illustrations and 3D Publishing provide users options on how they wish to work, either exporting an assembly into technical publications document or opening a Solid Edge file directly within the product. Here we'll use a delivered template to create a set of work instructions for replacing the motor on Bernina sewing machine. Each page will be made of a storyboard containing illustrations. We'll use the first page of our template as a cover page. As is common with the first page of working documents, safety instructions come first. As we already have the sewing machine in the model area, we can simply create a new illustration and use one of the many delivered industry images to show that the work being done needs to be completed with the unit powered down and unplugged. The second step to the instructions deals with gaining access to the motor assembly. We can easily guide end users on how to remove the back cover with another delivered image. Of course, as we're working with 3D geometry, it's necessary to change the orientation of the image depending on how you want them to appear. Changing the grid orientation allows us to place our arrow exactly how we want it, perpendicular to the back cover. So we have two illustrations created, but we need to have a way for users to access and switch between them. We can easily do this with an illustration table. Illustration tables automatically look at our cover page and place all content illustrations in an interactive table so the end users can cycle through them with the simple click of a button. Of course, individual pages, fonts, and setups can easily be edited to fit all of your needs for how you want the output to look. Now that our cover page has been completed, let's move on to the next. An interactive table of content allows end users to quickly and easily navigate the document. But as this is automatically updated and associated to the pages, no further action is required from us. The next page includes a step-by-step instructions for removing the motor assembly. The best way to visualize this process is mimic it through a 3D view. Solid Edge Technical Publications not only imports all native Solid Edge exploded views, but also allows for creation directly inside the interface. Here we'll leverage this functionality by creating our own view and then automatically create a set of illustrations based on each step. First, we need to remove the back cover. There are several options for how you want to move the parts and the direction in which you wish to explode them. Here we use the coordinate system of the part to get access to the XYZ directions and pull each component perpendicularly on how they're placed. First is the cover, followed by the fan, then the belt, then belt drive, both mounting bolts and washers. Selection sets allow us to organize custom group of parts and subassemblies into name sets. These sets are convenient for easy selecting multiple parts at the same time in this case. Once exploded view is created, we use it to set up a step-by-step instruction from our storyboard. We can easily accomplish this using a tool called Storyboard Wizard that takes all of the exploded view steps and makes individual illustrations out of them. The Storyboard Wizard offers several options on how you wish to organize the illustrations, from reversing explosion steps for reassembly to individual illustration viewing position. For this, we'll simply create the images as seen on the screen, as it makes it easy to see all but one. As we need to be zoomed out a bit to see the removal of the back cover, we can simply override the viewing position and fix it individually. From here, all that's left is defining what each image is showing, from removing the back cover to removing the motor assembly itself. Notice that there is a space for adding any additional information necessary for the instructions. For the belt drive, washer, and bolts, we can quickly configure a parts list to show the specific parts for that specific exploded view step. Another part list markup as an illustration overlay to help identify exactly what parts need to be removed in that step. Finally, by adding a carousel view to the page, we have another way to easily navigate through illustrations within a storyboard. Now that the instructions for removing the motor assembly are completed, we need to show the final step of taking it apart. When we imported the QSM file into the 3D publishing, the primary display configurations used is the default. For this page, we just need to show the motor, not the entire machine. No worries though, with Solid Edge 3D publishing, we can create one on the fly or easily leverage an existing configuration. For this page, we intend to show the motor disassembly, so we need not only the collapsed view, but an exploded view as well. Our first illustration for the collapsed view is simple, as the display configuration is already showing the motor in that step. For the exploded view, we can easily leverage one previously created inside of Solid Edge. Here, since we are only viewing the motor assembly, we can change the interactive part list to show only parts associated to the assembly. Leveraging board that has already been done in Solid Edge is another great time saver when creating publications. Furthermore, a powerful and versatile parts list editor is also included and makes it easy to change the parts list based on our needs. In this case, we will add a new column to show the last order of each part document. Illustrations in place. Now, just need a few edits and we're set. We need to have some buttons that associate to the collapsed and exploded view created. In addition to predefined tables, Solid Edge 3D Publishing can customize interactive objects from any shape chosen. Here, using a rectangular shape to signify a button to change to the associated illustration. Once it's properly defined and styled how we want it, we can simply copy and paste, changing only the necessary setting to associate to the exploded view. Of course, one of the key factors in working between the products is ability to associate model updates when they take place. Solid Edge technical publications products have full associativity when revising models. When changes are made to the bars, simply click on the Update View button inside the publishing product, select the revised Solid Edge assembly or the exported QSM file associated to the revised assembly, and the software handles the rest. Maintaining this associativity allows you to create your technical publication alongside your CAD designs without worrying about the final version before you start. This process allows users to complete the deliverables and get product to market faster. Now that we got all the instructions created and imagery in place, it's time to look at the final process of publishing the document. There are 2 more pages at the end of the template, one of which we don't need. The great thing about Solid Edge 3D publishing is that the delivered template covers almost most of our needs, but if we need to alter them, we have full control of what our output will be. Now that our project is how we want it, we can choose how we wish to publish. Solid Edge 3D Publishing provides access to the latest file types for the industry standards such as 3D PDF, HTML5, and of course paperprint. We want to host these work instructions on our website, so we'll use an HTML5 output. For this project, we just need a simple file, but additional options are available for multi-page HTML publication. The great thing about Solid Edge technical publication is that end users can access the information without any additional action on their part. Our HTML5 output will open on any modern browser, and 3D PDF files can easily be opened and used without any additional plugin needing to download. Saving time and hassle when viewing publications makes for happy end users. Now let's look at the final result. You can see how Solid Edge technical publication products provide users with a fast and intuitive platform to create whatever publications necessary. With full customization capabilities of illustrations, full associativity for model updates, and industry standard publishing options, Solid Edge technical publications provide users with all the capabilities they need to get the job done right the first time. To summarize what we saw in the demo, with the help of the Solid Edge technical publications, users can easily create powerful documents and quickly and associatively update the document when the design changes. With the ability to import configurations, exploded views, and many more information from the Solid Edge model, creating technical documentations have never been easier. As we saw in the demo, technical publication has beneficial impact both internally for manufacturing companies, helping them improve their product development and manufacturing performance, and externally, helping their customers to maintain their products correctly. This results in lower warranty costs and higher customer satisfaction. Less time for designers to answer questions from other departments and manufacturing engineers creating the documentation. Reduce error because the documentation is associatively linked to the CAD design. And consumers have more clarity because the documentation is dynamic and not just a static text and images. Let's not forget the downstream benefits with overall customer satisfaction, with products being delivered on time. Products are also installed, commissioned, and maintained more correctly and efficiently, resulting in lower operating costs. Now let's look at Solid Edge MBD, which is another great tool within the Solid Edge portfolio for creating product manufacturing information. What is MBD? MBD is a set of tools for authoring, engineering, and manufacturing information in 3D and publishing that content to 3D PDF and other formats. Model-based definition, or MBD, has been around a long time. In the past, if there was a disagreement between the 3D model and the drawing, the 3D model was considered the correct answer. In reality, that was very difficult to enforce though, because the only place that had easy access to the digital model was the engineering offices. Today, that story is much different. Digital technology throughout the enterprise means that access to digital twin is everywhere. Also, more than that, MBD has come to mean much more. How do we integrate MBD today? Let's take a look at some of the enabling technologies. PMI stands for Product Manufacturing Information. You can think of it as geometric dimensioning and tolerancing applied to a digital model. It covers dimensions, sure, but also annotations, feature control frames, section views, and tolerances. PMI inside your CAD tool is nice, but the real benefit is the ability to transfer that knowledge to downstream users like manufacturing and quality assurance departments. With Solid Edge, PMI can be exported to Solid Edge CAM Pro or NXCAM via the lightweight JT option, but also with PLM XML technology. The same process is used to send PMI down to TechPubs. Synchronous technology, by nature of its design, was made for MBD. Unlike other CAD systems, where you create or edit the solid model, the dimensions are transferred directly to the model. I can't stress how important this is. You no longer have to rely on some dumb sketches. You can edit the model directly by editing the dimensions on the model. Take a look at the image. The user is editing the model by editing the dimensions. Now, this is not a demo magic. This is not a smokes and mirrors. It's the way that synchronous technology works. After creating the PMI on a 3D model, users can create and publish company-specific configurable templates and effortlessly publish the technical data packages from Solid Edge using the tools as seen here. Now let's quickly see a demonstration of MBD in Solid Edge. Solid Edge model-based definition provides new ways to seamlessly consume 3D models in an intelligent way for downstream manufacturing applications, or just share with relevant stakeholders. Let's start this demonstration with a quick refresher on product manufacturing informations, also referred to as PMI. Solid Edge has always had some great tools to add PMI dimensions and annotations onto 3D models. In this example, the part file has some specific dimensions that have to be communicated for manufacturing. Model views are a great way to communicate dimensions and annotations related to specific views. As you can see, this model view now contains dimensions relevant to the top view. Switching between model views is quick and easy. We will now add an annotation to represent the hole pattern, count, and size. Intelligent attributes allow quick retrieval of features such as holes, patterns, rounds, and more. Solid Edge also allows tagging multiple features or faces for specific manufacturing nodes like tolerances. In this case, maximum material conditions with respect to multiple datum frames have been specified and tagged to the inner hole pattern. Solid Edge MBD allows designers to publish 3D PDF documents using templates. Let's take a look at how quickly and easily custom templates can be created. The template editor environment provides users the flexibility of placing and resizing various elements like 3D view, a view carousel, bill of materials, and free text boxes. Publishing 3D PDF documents is simple. A single dialog enables standards or custom template selection. We will use one of the standard part templates. Required model views can be selected, automatic step or JT files can be generated and added as an attachment within the 3D PDF. We also allow adding additional attachments, which we shall see in the next example. Once the 3D PDF is published, a high quality output is generated. Required model view with relevant PMIs are available. Standard views such as front, top, side, and isometric views are automatically published. Geometry view manipulation is supported for better insights into the model. Templates can be either single or multi-page. Notice the level of geometric details in the view. On the side panes, you can get access to the model tree and attachment sections. From here, you may choose to open or save out selected attachments. Let's move ahead and take a look at some of the other capabilities. Section views are an easy way to view internal details of a model. The new section by plane further simplifies the way with which users communicate this internal detail. With support for up to 3 different section planes and accurate controls over the cutting plane angles, even complex assemblies can be sections as required. Want to eliminate specific parts from being sections? No problem. Let's eliminate this basket and the basket handle. Just a few clicks and the desired output is achieved. As we just saw, this new feature saves significant time spent on sectioning complex models. Before publishing the model, you can also review model views to ensure they contain the necessary details. Once done, you can either create a new custom template or use existing ones. Let's go ahead with the out-of-the-box landscape view assembly template. Remember, we talked about adding additional attachments. Just browse to the location and select from a wide range of supported file types. These attachments would be embedded into the 3D PDF document. Apart from standard elements like 3D view and view carousel, assembly 3D PDF documents can also contain bill of materials. The bill of material is interactive. Let's take a look at how this bill of material enables interacting with the 3D view. By selecting a particular view, in this case isometric, the consumer of the document can either select a part in the graphic area and the relevant line item is highlighted in the bill of material, or vice versa. Another way of interaction is via the model tree. Select a part on the model tree and watch it highlight in the graphic area and bill of material. Very useful. The attachment area, as you can see, contains the auto-generated step and JD files, and also the user-specified documents. In summary, Solid Edge model-based definition provides flexibility by leveraging critical design details of the 3D model and converting them into interactive document. Now let's talk some next steps. To learn more about Solid Edge 2022, visit us at siemens.com/solidedge2022 or simply use your smartphone to capture the QR code that is pictured here. If you're not already a member of the Solid Edge community forum, I highly encourage you to join. Once a member, you'll get access to a wealth of knowledge. You'll be able to browse blog posting, read articles, and hear about the latest news from Solid Edge. You can also ask questions, exchange ideas, and benefit from other users' experiences on our moderated forum. And finally, you'll have access to our extensive knowledge base from which you'll be able to increase your skills. So go ahead and join right away. Now, thank you for your attention, and if you have any questions, you can contact me via email.